So the next sample I'm going to do is I'm going to try to figure out the best eluent for two different molecules, to separate two different molecules. So the two molecules I'm going to try to separate are benzophenone. Actually, benzophenone is just two ketones attached to, two phenyl rings, two benzene rings attached to a ketone. There's benzophenone. And I'm also going to use vanillin. We're chilling with vanillin again, 99% pure. Vanillin. Vanillin. V-A-N-I-L-L-I-N. And vanillin, it's a benzoic acid derivative. It has the carboxylic acid here. And no, it's an aldehyde. It's a benzaldehyde derivative, that's right. I'm trying to remember from memory here. It's a benzaldehyde. This actually right here, benzaldehyde, that's the smell of cherries and almonds, and it's a liquid. Oop. But if you add one more thing to it, I believe it's a methoxy. You put a methoxy here, and now it's vanillin. Oh, wait, I think I need a hydroxy here. Pretty sure that is vanillin. Let me double check. I had it wrong. I looked it up. It is a benzaldehyde. It does have the para-hydroxy, but it's not orthomethoxy. It's metamethoxy over here. So that's vanillin. And it actually smells nice. It's the principal, I think it's the principal component in vanilla extract. It's got that nice, like, feels like you're baking a vanilla cake or something. So let's make up a sample of that first. I'll get a test tube and I'll label it with my initials, the date, 4/16/21, and this is going to be benzophenone and chillin' with vanillin. And to prepare it, I just add a pinch of both of them. Easy enough. So get a little bit of benzoin first, maybe. Benzophenone. Did I put benzophenone? Yeah, I did. So benzophenone, I'm going to add that first. That should be enough. Got it. TLC is great, like I said before. You barely need any sample. If it's something precious that you don't want to waste, then it's perfect. You don't need much to use. You don't need much. Okay, so now a little bit of the vanillin. Chillin' with vanillin. Nice white crystalline compound. There we go. And I could dissolve it in acetone, that works, or methylene chloride, or any organic solvent that will dissolve the two, and then when I spot on the TLC plate will evaporate quickly. Anything like that will be fine, because it's just a solvent to move the sample, just to transfer the sample to the TLC plate. So I'm going to use acetone. I've got acetone, so it's right here. Squirt some in there, and yeah, do like a little more squirt. That looks good. Looks dissolved to me. I'm ready to go with that. And then my TLC plate, my recycled TLC plate, I'll label it. Oh, I'm going to be using multiple TLC plates for this. So what I'm going to be doing is I'm going to check three different solvents to see which one separates the benzophenone and vanillin the best. So the three solvents I'll test are acetone, you probably should know the results of this already. Acetone, hexanes, and when it's hexanes, that means it's a mixture of 6 carbon alkanes, so it could be just N-hexane, 1-methylpentane, 2-methylpentane, or 2,2-dimethyl butane, that kind of thing. So it's a mix of all this. It's just a very non-polar solvent. We got hexanes. And then the final one we're going to use is a combo one. It's a 50%. It's a 50-50 mixture of ethyl acetate, which is the following ester. It's looking like it could be acetic acid so far, but we put the ethyl on there, it's an ester. So it's the ethyl ester of acetic acid, ethyl acetate, and toluene. So we have that mixture. So oftentimes we use mixtures of solvents to get the polarity we want for our eluent. And toluene, remember, is just a benzene ring with one methyl. So that's a single solvent mixture. Let's try, I kind of know how this works. I'm going to start with hexanes. Oh, and let's also remember, so this is our mobile phase. That's the solvent moving up. Our stationary phase is still silica, which is basically like sand, beach sand, silica, and glass, silica. And it is polar. It's got all those silicon, oxygen, OHs on the outside of its surface. So silica, polar. So a couple questions we got to ask is who's more polar out of the two of these, because whoever's more polar will stick more. And then which solvent is best to move it up the TLC plate, but not too fast where they don't have time to separate, but not too slow where they just barely move at all, but you want it to move just right, like Goldilocks and the Three Bears. Okay, so let's label this recycled TLC plate here. I'm going to spot, oh yeah, I forgot, I was gonna make individual samples too. So this is the benzophenone vanillin. I'm gonna spot vanillin by itself, and then I'm gonna do a mix of the two, and then I'll do a mix heavy and a mix light, and then I'll do the benzophenone here by itself. So I actually have to prepare two more test tubes. So the benzophenone test tube and the vanillin alone test tube, I'll do those off camera. Okay, let's start spotting. So I'll put the vanillin on first, this vanillin here. I made up a test tube of that. It's the unknown from before, vanillin and a little bit of acetone. So I'll stick my capillary tube into that, and it's gonna draw up by capillary action some of that vanillin. And then this vanillin I can spot on the paper towel to get rid of most of it. Oh, we really went up far on this one. Okay, and then I'll come over to my TLC plate and I'll label it. I'll spot it. Let's see if it works. I'll get a little closer for you guys, so you can see it better. Okay, here we go. Oops, the daisy, I broke my capillary tube. It might still work with the end. Let's see, 1, 2, 3. Yeah, it worked. Did you see it? Put this in my little waste beaker. Okay, now next up is the mix. I didn't even have to make a mix, benzophenone vanillin, but I'll use it since I made it. So the mix, I could have just spotted the benzophenone and the vanillin from their vials separately onto the same spot to make a mix, but I have the mix, I'll use it. Okay, so here we go. I'm gonna spot onto the heavy one first. Boom, and then the light one. And then I'll go back and I'll do the heavy one again. Oh, I kind of did a bad job with that. And again, so I got 3 spots for the heavy, so it'll be heavier. Lastly, I'll do the benzophenone by itself. Screw that up. Drain most of it off. Come over to the benzophenone and give it a tap. There it is, done. Now I will bring it over and look at it under the UV light to make sure I did a good job and I got enough sample on each one. So I have it in there, turn it on, cover up the front so the camera is better. Okay, so let's zoom in on this. It looks good. You can see, if you look carefully, you'll see the spots where I spotted them, right? Benzophenone, the mix light, mix heavy, and the vanillin. And then at the far end of the TLC plate, you can see the last sample that was pushed to the top. That shouldn't interfere because I'm going to run my Eluent. Sorry, I turned off the video. I'm going to run my Eluent, and it'll stop it before the previous samples at the top. So let's do it. The first Eluent I'll check is the hexanes. So hexanes. And I will get another filter paper, put that in there, and then add the hexanes. Okay, I got some Wattman 12.5 centimeter filter papers. Just tear it in half. Put that in there. And now my hexanes, I grabbed some hexanes from the flammable cabinet. Here's my hexanes. I'll initially draw up some hexanes and then push it back in the bottle because I want to evaporatively cool pipette so it doesn't shoot out on me like an elephant. And then I will start adding it to my beaker. I want to wet the wick, and I also want to just add enough to coat the bottom of the Eluent chamber. I think that's enough. Yep. And then I will grab my TLC plate. Once again, I'm going to add it so that it's not touching the wick. It might try to draw solvent off the wick. And it started below my spots. It's already traveling up, but it was initially below the spots. And then I'll put a watch glass over the top of it and wait for it. While I'm waiting for that, I'm going to spot another TLC plate for a different solvent. So I've got a new TLC plate here. The recycled one's running, so I'll draw a line about 1 centimeter off the bottom. And I'm going to do I'll do it the same order. What did I do initially? I did vanillin, mix heavy, mix light, benzophenone. And then I'll put my initials up here. Oh, I forgot on the last one I should have written hexane. So this one I'm going to try acetone. Acetone alone. And I'll put the date to 4/16/21. There we go. So let's spot this one while the other one's running. Oh, let's look at the progress. So the one that's running in hexane, the hexane's risen about 1/3 of the way up. So that's looking good. Now I'll spot this one. Get my capillary tube. I want vanillin first. Vanillin alone. Here it is. Chilling with vanillin. Put my capillary tube into the solution. Pull it out. And first drain it mostly onto a piece of paper towel. And now I can spot it on my TLC plate. And let's see if it's visible for you guys. 1, 2, 3. Oh, I think that was a nice little one I got there. Okay, I break off that tip, put it in the waste container, get my mix. So here it is, benzophenone vanillin mix. Paper towel, real nice. A little more. Okay, so this is the mix. So let's go mix heavy, spot light, spot heavy again, heavy a 3rd time, boom. Okay, looking good on that one. Put that in the waste container. Grab my benzoin. I'm sorry, benzophenone. There's too many Ben names, huh? benzophenone. Put that on the filter, on the paper towel, drain it mostly. All right, and now benzophenone. Boom. Oh, I didn't spot that one great, a little above the line, but I know it, I'll remember. I think it'll be okay. All right, so I've got those all spotted on there. Let me make sure, though, by putting it in the UV light box. Short wavelength, 254 nanometers. Oh my goodness, I did a horrible job with this one. Look at that. It's got spots all over it from the, I think my tip was leaking all over it. Oh man, that's crazy. I'm gonna run it anyways, just see what happens. See if we can follow it. Interesting, but I'll spot another TLC plate. Before I run, well, actually, I'm gonna run this one, yeah. I'm gonna run this one in acetone, right? Yes, this one, the spotty one. So I'll open up my acetone chamber and grab my TLC plate. The spotty one, I put spotty on it. And I set it in, let me actually set this down. Set it in so that it doesn't touch the wick, it just touches the glass wall. There we go, I think I did a good job. It looks like the solvent started below the spots. Yeah, it's climbing up slowly. All right, that one's going okay. Let's cover it up, set it aside, and let's pull out our hexane first run. And remember, when we pull these out, you have to right away label the solvent front because it evaporates. So right away I see it, it's right there. It's right below our last samples. So I put the solvent front line right there. So now I shake it, shake it like a Polaroid picture. And then once it's evaporated, I'll put it in the UV light box and see how it went. I think it's pretty much evaporated already. Good. Oh, yep, the light's already on. I should have turned it off for the last run. I should have turned it off first. Okay, so what happened? Look at that. I kind of, this might be confusing. The plate's in backwards compared to when I first looked at it before we ran it. Let me turn it around. Okay, so there we go. So what happened? It looks like the spots really didn't move from the baseline. They're just stuck there. So does that make sense? Hexanes, very nonpolar. Yeah, it makes sense to me. It's just not polar enough. It's not going to pull the molecules up. So they all pretty much stay on the baseline. Since they're all pretty much on the baseline, what we can do is now just run this sample as is in the next solvent. It looks like the benzophenone moved a little bit, but not too much. I think it'll be fine. Let's try running it. If it doesn't work out well, we'll run another one. And the last sample on the far left, that's just still sitting up top there. So I'll record this data still though for our experiment. It looks like the spots really didn't move. They just kind of broadened out. I wanted to prepare one more solvent chamber. The hexanes didn't work, it wasn't polar enough. So what I'll do is I'll take the wick out of the hexanes chamber. And actually the hexanes that was in here, I poured it into our waste bottle in the fume hood over there. And now this wick, I'll just kind of shake it around to dry it out, and I'll reuse it for the next solvent chamber. So I'm gonna actually set it on over here, and then I'll take this over, and the hexanes will evaporate pretty quickly all on their own. But just to make sure they're gone quick enough, I'll do the rich man thing. I'll use the nitrogen tank. So it's currently loose here. It's closed at the top. I'll open it first at the top, and then I'll turn it on here to get a little flow going. Hear it. And then I'll bring my beaker over, blow that for like 10 seconds, and that residual hexane will be gone. And now it's clean and ready to use for the next solvent. So I'll turn off the flow here first, so nothing's being let out anymore. And then I close the top, just in case this regulator leaks. Let's bring this over and get it ready for the next solvent. So it's no longer hexanes, it's going to be 50%, it's going to be 50-50 ethyl acetate / toluene. And my wick that had the hexane on it earlier, it's completely dry already. So I can put that in here. Get my ethyl acetate toluene mixture, which is this guy, 50% ethyl acetate, 50% toluene. Drop the cap. Grab the cap. And pipette some of this solvent in and then spit it out. Do that a couple times to get the pipette evaporatively cooled. And then I can start filling up my beaker. Just coating the bottom of it so my spots can be above the solvent level when they start. Usually, this is a 150 milliliter beaker. It's about 3 pipette squeezes for me, maybe 4. I can smell that toluene already. Toluene has a smell of, like, it reminds me of like model airplane glue. Yeah, there we go. So I have that ready. I'm using this the hexanes run because the spots didn't move. So I'm just going to use it again, and I'll set it in the chamber so that it's not touching the wick, and make sure the solvent level starts below the spots. And it looks like they are. It is. Cover the top and let it run. Now I'll pull out the acetone run, the one with the spotty sample. And again, I pull it out and right away mark the solvent front before it evaporates away. And then shake it, shake it. Or shake your booty. Ow! Shake. You don't have to shake it, but it's fine. So anyways, we got our sample here. Let's put it in, and yeah, I think it's turning out the way I was expecting. So if you look at this, it's just got a lot of sample at the top of the run, huh? Let me turn it the other way. I think the other samples I've been showing you is going the other way. So you can see the spots started on the right there, and they just got pushed up. Even the little splatter spots, everything just got pushed and mixed together. So basically, the acetone was just cleaning this plate for us. I'll actually put it back in the acetone and run it these spots even higher up. So yeah, this acetone as an eluent for these molecules, it's not good. It's too powerful. And so the hexanes was too weak. This acetone is too strong, and hopefully the 50-50 ethyl acetate toluene is just right. Okay, I'm going to be pulling my TLC plate out of the 50% ethyl acetate, 50% toluene. And I want to immediately mark the solvent front. Do you see it? It's like right there. It's already evaporating. Got it. This was an old solvent front. I better cross that one out. Okay, and now shake. Shake your booty. Ow! Shake your booty. Ow! All right, so this one, something interesting is going to happen. Giving you a little foreshadowing. It's still pretty wet. Let's go put it. Let me say this. The other samples that we ran, by this time the solvent would have evaporated. The acetone, the hexanes. Let's put this in the UV box and see what it looks like. Putting on the short wavelength, and look at that, the whole thing looks just pink, but you can kind of see some spots. What's going on? So what's going on here, this is something you should know about, is that one of our solvents, toluene, has not evaporated enough. Not only that, but toluene has conjugation. And so it's basically an organic molecule that's coated the whole surface. So if I look over here again, toluene is organic and it's conjugated, so it's making the whole slide that has toluene still on it pink, so you can't really see your spots. So all that means, all we have to do is just wait a little while, let it evaporate a little longer when you have the solvent toluene. Because the boiling point of toluene is about 110 degrees Celsius, so we just have to do a little more shakes. Shake, shake, shake. Shake, shake, shake. Shake your booty. Ow! And you can smell toluene pretty easily, right? So if you let it sit out for a few minutes and then come back and waft at it, like, you can tell if you can still got the toluene on there. Let's look at it now. It's been, another minute or so. Okay, now the spots are starting to show up, huh? Because you can still see a lot of toluene though. See, that's kind of pink, but there's spots there. I don't know why my video is not so good on this one. Come on, focus, focus, buddy. Doesn't want to focus, but oh well. There it is, that's better. Yeah, so you can still see a lot of toluene, but you can see your spots as well. And hey, what do you know? The vanillin, it looks like it's lower, right? It's got a lower RF, and I would have guessed the vanillin was more polar as well, so that makes sense. So the vanillin is lower, has a lower RF, and the benzophenone has a higher RF, so we were able to separate the two molecules with this solvent combo, with the 50% ethyl acetate, 50% toluene. Whereas if you remember, the hexanes didn't move the spots at all. That wasn't a good one. The acetone was too strong and moved them all to the top. So but we found our just right solvent for these two molecules to separate out on silica TLC. And and then also at the far right, you see the last runs. The recycle, because this is a recycled TLC plate, and the recycled TLC plate worked good. So I'm going to circle those spots under the UV so we can get measurements. I circled the spots while it was under the UV light, and I put a little dot in about the center of them. That's what we'll measure for RF. But the first thing we'll measure before that is the solvent front. So I put the ruler at 0 for the solvent front, and then it comes to, it looks to me about 5.2 centimeters. Let me see, let's look at it closer. What do you think, 5.2? Yeah, we'll go 5.2. And now let's measure, so the benzophenone, that one's a higher spot. Let's put this at about the center of that one. So benzophenone, that looks like it's coming out at about 4.1 centimeters. That's good. And the vanillin looks like 2.85 maybe. I like it. So there we go. We can calculate RFs with this.